Hexmate is a utility that can perform many tasks with hex files. Whenever you add a hex file to the MPLAB-X IDE's Loadables folder to have it merged with your project code, the IDE is running Hexmate for you. It's also executed if you ask the MPLAB-XC8 compiler to generate a checksum or CRC value in the IDE's project properties. But if you are not using the IDE or the MPLAB-XC8 compiler, you need access to options which are not available from the IDE or compiler, or you simply prefer to run the application as part of a customized build script, then this webinar will show you basic usage of Hexmate using its command line interface. Hexmate can be found in the bin directory of the MPLAB-XC8 compiler. It is also in the bin directory of the MPLAB-X IDE. Note that if you wish to browse the IDE directory in the Mac OS X Finder, you will need to right-click and select Show Package Contents before you can navigate to the IDE application directory and then the bin directory. If Hexmate is in your path, run it using the command hexmate, followed by the required options and files. You can use the -help option to list all options, or obtain help about a specific option using -help equals and the option's name. In this presentation, we'll look at a few of Hexmate's features and options. Hexmate works only with hex files, in particular the Intel HEX format. These are text files which hold device data to be programmed. They consist of a number of lines called records. Each record consists of a :start code, a 2-digit count, being the number of data bytes in this record, a 4-digit address, a 2-digit record type, the actual data, and a 2-digit checksum. All digits are in hexadecimal, and note that the presence of the record checksum means you cannot manually edit data in the record easily. The two common record types are 00, being a data record, and 01, being the end of file record. The other record types deal with addressing, and we'll look at some of those a little later. One advantage of the hex format over binary files is that each record contains an address that indicates where that record's data should be programmed. Hex files, therefore, do not need to contain data for device memory which is not to be programmed. But care is needed since the hex format uses byte addressing, which means that each byte of data has an address one larger than that of the previous byte. And this can lead to confusion when working with those Microchip PIC devices that have word-addressed program memory. Take a mid-range PIC device, for example, where each instruction is 14 bits wide. The hex file that programs such a device would use 2 bytes of data to specify each addressable word in the device. Thus, address 0 in the device will be programmed by the bytes at address 0 and 1 in the hex file. Device address 4 will be programmed by the hex file bytes at address 8 and 9. All addresses specified with Hexmate options represent addresses in the hex file, but typically you prefer to work with device addresses, so you might want to use the -addressing option. This option allows you to specify device addresses in Hexmate options and have Hexmate map these to the addresses in the hex file. Specify an addressing value of 2 for all baseline, mid-range and 24-bit PIC devices. Use the default addressing value of 1 for all other devices. Hexmate is often used to merge the data in 2 or more hex files so that all the data will appear at their original addresses in the one hex file. A typical command to perform this is shown here. It lists all the input files and uses the -O option to place the merged data into the named output file. Without this option, the output is printed to the standard out stream. During this process, a data conflict error will be flagged if the input files contain data with different values at the same address. Typically you want to read all the data inside an input hex file, but you can restrict the range of data read by Hexmate by using a file specification before the file name. To restrict the data read from test.hex used in this example, use the letter R an address range and comma before the file name. And don't forget the -addressing option, since you specify addresses with this command. We have seen that hex files use a 16-bit address with each record, which limits data to 64K. To allow data at higher addresses, other record types, such as the extended linear address record, code 04, can be used to specify the upper 16 bits of the address for all the records that follow. The Hexmate -format option controls whether the extended linear address record is used in the output. Some debuggers require these records, even if they are not needed. Some debuggers can't process them. If you have written a simple bootloader that accepts hex files, this option might help ensure the file is in the correct format. This option also allows you to specify the maximum number of data bytes contained in each record. The default is 16. To change it to 8, for example, follow the format type with this number. Hexmate can be used to modify hex files by inserting strings, serial numbers, checksums, or CRCs. Unused memory locations can also be filled with values. As an example, the -serial option in its simplest form inserts a value at the address you specify. So the option shown will place the byte 55 at address 200 in the hex file. Notice the -log file option was used. Log files contain useful information, and when using the -serial option, for example, you will see the serial address confirmed in the listing and in the memory map. For full information on the features and option formats available in Hexmate, consult the Utilities chapter of the MPLAB XC8 C Compiler User's Guide.